Okay, I'll begin. So just to make you aware now, in this section here, I have put up a pre-recorded lecture and it's talking through these slides here, and in the lecture I explain the design kind of process that the React team advise you to go through when you're developing a React app. So like it is, if your starting point is you've got some sort of outline of what the UI is meant to look like, you've sketched it out on pen and paper, or maybe you've used some tool to sketch it out for yourself, and you've got a sense of how you want the UI to behave in terms of the user interaction and all that kind of stuff. So that's your starting point. How do you go from there then to coming up with a component hierarchy? How do you then decide which components are stateful and stateless? How do you decide what is state for your particular app? All of those kind of questions. I'm trying to explain the process that you go through in this lecture. It's about 40 minutes long or so. So you will need to watch that in your own time. And as I said, the slides are here. I've kind of followed the process in the Movies App Labs at the beginning. Anyway, the very first part, I certainly followed it. And maybe in the second part, maybe from part 3 onwards, I kind of, well, it's not so much that I deviate from it, but I park it kind of at that stage and just start adding in little bits of code here and there. So you can look at that in your own time. So for this lecture, though, I'm going into this card here, and the slides are here. There'll obviously be a lab with in this section as well, and the lab will be part 4 of the Movies app, and that is the last part. It's quite long, part 4, because we've got a lot of kind of bug fixing to do and little other features to add. And then that will be the end of the lab, of the Movies app lab. So I should have it completed by, well, certainly by Wednesday, because I have all of you, or some of you for labs on Wednesday. So it'll be completed by then. So just keep an eye on this page here, and if it appears, then you're ready to work on it. If you are ready to work on it, if you have finished part 3 already. So today, anyway, today and this week, really, I want to wrap up a number of things, because this is actually the last week that I will have you for lectures. Frank will be taking over the show from here on in, Frank Walsh. So I want to do a little bit more on navigation. I want to do a bit more on design patterns. I also want to look at another hook. So there's a mixture of things. So this is very much a continuation of the navigation stuff that we've already looked at. And we've worked through some of the samples. So the next sample, I want to address an alternative usage of the root component. So in the root component there, and you can see an example of it, we provide 2 props. We provide a URL path and a component. And we know the way it works. If the browser's URL matches the actual path string, then what React Router will do is it will mount the component that you've specified there. The problem, though, is what if we want to pass some props to that component X? We've no way of doing it using this particular form of the root component. So there is an alternative form that we can use. And it looks like this. So instead of the component prop, we have a prop called the render prop. And the render prop, you actually give it a function, a callback function. You can have any logic you want in that function, but critically, the function needs to return the component that you want to have mounted. Now, typically in the logic, you might actually initialize these extra props that you want to pass into the component. So you're free to do whatever you want to in there in the function, but critically it returns the component to be mounted, plus presumably these extra props that you want to pass into it. So by way of illustration, you can see the code in sample 7. I don't think I need to look at it in VS Code. I can just explain it to you from the slides. So and now it was just a random kind of illustration. There isn't a whole lot of meaning to it, but you may remember from an earlier sample 4, I'm saying there, I had a stats component. Now it didn't do anything other than display a string. But supposing my stats component, I wanted to pass in some statistical data that was computed somewhere into that component so that presumably the component could display that data. Now back in sample 4, this was the root entry that uses the stats component. I think it was a nested root anyway, but that's only coincidental. So obviously that's no good to me the way I'm using it there. And as I said, now I want to pass in some usage props data. So instead of using the root component as I am there, what I can do is do it like this. And so here's my my new prop called the render prop. I'm giving it a callback function. Now, okay, I don't have any logic in here, but you may well have in general. And here's this extra custom prop that I want to pass into it. And again, okay, I'm just hardwiring some data for now. That's fine. So there's there's my extra custom prop that I want to pass into my stats component. What's actually going on over here is you can see that the callback function allows for an argument. And what that argument is, or parameter is the props object that would ordinarily be passed into the mounted component. If I go back to the previous slide, you know, when this component is mounted using this, when the stats component is mounted here, it does receive a props object, but the props object is created by the React router. And it does have some useful props, but it has none of ours. It has the history prop, which we haven't seen. It has the location prop and the params, match.params, you might remember. So it has all of those React router related props. And that's the same props object here, right? And all I'm doing here is I'm taking that kind of default props object and I'm just using the spread operator to spread out its individual key value pairs, so that there may well be some of those React router props that I still want to use inside my stats component, in addition to this custom prop of my own. So that syntax looks a little bit odd, but I'm just taking an object and I'm spreading it out into its individual key value pairs. And the reason I'm using curly braces is, well, that's just a JSX thing, isn't it? I have to wrap any kind of variables in JSX. So that's all that's going on there. It's kind of boilerplate, really. And here is my stats component now at the bottom. And of course, I can now do props.usage. I can access my custom props. And here's the prop that I'm actually, what is it doing? It's pulling off the user ID or the inbox ID from the URL. This would not work if I had not done this up here, you see. So the overriding point anyway is if you want to pass some custom props into a component that's part of a route entry, then you should use this form of the route entry as opposed to the one that we've been using up to now. And I do that in the labs as well, or an occasion arises where I can use it. Programmatic navigation. Up to now, the only way we can achieve navigation within our app is through hyperlinks using the link component. But there may be cases where you actually want to program navigation into your JavaScript. You know, the user does something that triggers a function, and within the function, it makes a navigation, or it tries to change the browser's URL, tries to implement navigation programmatically, in other words. And okay, there are actually two ways that we can implement it, and it's very much a question of whichever you prefer to use, really. There's a declarative approach and an imperative approach, and they both do the same thing. If you use the declarative approach, then you have to add a particular state variable to your component that's going to have the programmatic navigation, and you will also use the redirect component, as we'll see in a second. If you implement programmatic navigation using the imperative, then there is a special prop called a history prop that you can use to achieve it. The kind of classic example of this I am programming, or I'm implementing in sample 8, and it's only a skeleton implementation now, but you know, if you have a website and there is a registration button on it, and you click the registration button, and when you click the registration button, it typically brings you to a registration form. You fill out the form and you click the submit or register. And presumably when you click the register button, some bit of logic runs behind the scenes, maybe does some validation, it writes your details to a database. And typically then it sends you back to the home page. So it does this. Now the last arrow there, if I'm implementing this website in React, the last arrow is an example of programmatic navigation. Okay, so, and I've implemented the registration in a declarative way and in an imperative way. So that's why I've got two kind of registration buttons here. So what's only new here now is how do we achieve that? Okay, and let's look at the sample, which is sample 8. So again, the behavior is going to be click on your registration, brings you to a registration form. I didn't bother having a web form. That's not what's important here. What's important is when I click this, brings me back to the home page. Same behavior exactly for the first one. So let's have a look at the code. So my home page, I've got my two hyperlinks, and I've just associated these URLs with the two implementations. So register D implements declarative and register I imperative. So let's follow the register D one first. Okay, so when I click on this link, that pushes that onto the that path onto the browser's URL, and according to my routing logic, that's going to mount this component. So what's going on in there? That's obviously, this is obviously going to display the registration form for me, even though there isn't a form. So this is the declarative implementation of programmatic navigation. And I said, when you implement it in a declarative way, you need to just have a special, or you need to add a state variable that you will use to help you with your decision logic. So here's my state variable. You can call it anything you want to. You can initialize it to anything you want to, but typically we implement it as Boolean. So I'm initializing it to false, and I've just called it that, right? So I'm going to use this variable now essentially in the rest of the component. I'm going to use it to decide, should I send the user back to the home page, Or maybe should I redisplay the registration form all over again? So it's initialized to false. So if I just skim down, we can ignore that for a second. I've got a bit of decision logic here, which check to see, is it currently through? And it's not, so I'll skip over that for now. And it renders this. So it just renders my form with my button. My button has an on-click handler. So this is where the programmatic navigation comes in. When the user clicks the registration button, that triggers my little event handler here. I change the state to true. And we know when we change the state, the component re-renders. And so this time on the second rendering, this is now going to be true. And here's how I actually achieve the programmatic navigation. I'm doing it in a declarative way, and I'm using the redirect component that comes with React Router. And so by returning a redirect, effectively what happens is the browser's URL changes to this. And of course, we know that whenever the browser's URL changes, then the React Router examines its routing configuration. And according to my routing configuration, if it changes to, slash, then I go back to the home page. But it can be anything I want it to be. It doesn't have to be back to the home page, whatever you want, wherever you want to send the user to. So in summary, this is programmatic navigation achieved in a declarative way. In the imperative approach, this implements the same in the imperative approach. No state variable this time. And so let's just skim over. Sorry, now I'm just checking something. Oh yeah. So here's my registration form area, my button, my on-click handler, trigger a function when the user clicks the button. And here's my programmatic navigation done imperatively. So there's this special prop called the history prop, which is another one of these extra props that the React Router makes available to a component. And it looks like that history prop has a method called push. Essentially what you're doing here is you're pushing this string onto the browser's URL. And so if the browser's URL changes, we know what happens as a result. So this is imperative style programmatic navigation, slightly less code, I guess. So it's a matter of choice really as to which you use. The history prop is only available to you if you use this special function down here. You have to wrap the component that has the programmatic navigation. You have to invoke the with router special function, passing it that component. And by doing that, the history prop is now available to that component. So that's programmatic navigation. That's how you achieve it. It's as simple as that, really. And I think that's all of the routing stuff that we need to know about. I'm sure there are some other odds and ends, but everything that I've used in the lab, and I'm pretty sure everything that you will need to use in the first assignment, in terms of navigation anyway, has been covered by all of those. So the React Router library is kind of nice. It allows us to express our routing logic in a kind of declarative way. And it does essentially follow that kind of event state change re-render kind of process, the state change being the change that happens to the browser's URL. That's kind of the event, sorry, that's the event that happens. Browser's URL changes, that triggers, okay, the state changes within kind of the React router logic itself, but it also causes re-rendering or mounting and unmounting of stuff to happen. So that whole kind of cycle, which is a React cycle, is honored by the React router library as well. These are some of the main components, third-party components that the React router makes available to us, and we've seen all of them. There is this special function that we've had to use a number of times whenever one of our components wants to access React router related props. For example, the match prop and the history prop and the location prop, we've seen all of these. Back to design patterns. This was a slide from Thursday's lecture. We talked a lot about reusability and separation of concerns, and then we talked about some patterns that you can use in React to achieve reusability and improve separation of concerns. We looked at the container pattern. Today, I just want to look at the render props pattern. And surprise, surprise, the pattern is all about sharing logic between components, which is kind of a running theme through all of this. A definition which usually doesn't make a whole lot of sense until you see examples, but what do I mean by, or what is meant by a render prop? We know what a prop is. What distinguishes a render prop from any other prop? I'm saying there that a component that receives a kind of a render prop, what you assign to, you see, what I've set up to now, sorry, if I just backtrack a little bit, what I said initially when I talked about props was props are the way you pass data from parent to child. But then later on, I actually said that you can assign a function to a prop. And the way we used a function as a prop was when a subordinate component needed to tell a parent or at least a superordinate component that an event had occurred, like the user clicking on something or moving something, and the superordinate component, it provided a function to the subordinate component so that the subordinate component could call that function. And typically in the function, then the superordinate component carried out some sort of state change. But it was this idea of passing a function down to a subordinate. Now, what a render prop is, it's also a function that you pass into a component, but the purpose of the function is essentially to provide some JSX for the component that is receiving the function. And so the component that receives the render prop function will call that function, but it will call it in the middle of its JSX. And of course, the function returns some JSX. So we're essentially injecting some new JSX into the component that receives the prop. Let's see an example. Right, so I have shared component here. It does very little purposefully, but you can see one of the things in the middle of its JSX is sorry, there shouldn't be a this there. That shouldn't be there at all. There's two errors actually. I should have props here, and here it should be just props.render. So in the middle of the JSX, I am calling a function. And so whatever that function returns is going to be mixed into the JSX here. Here's a component that actually uses the shared component at the top. And it's assigning to the render component, it's assigning a function, which is right. And the function is indeed returning, in this case, something very simple, a span. So when this component is mounted onto the DOM, this is what is going to be appear in the, this is what's going to appear in the actual DOM for that component. The div is coming from up here, and the span is coming from here, which has been essentially achieved by calling the render function, the render prop function. So the shared component, which is this one. So any other components could now use this, but in its render, it would provide some other type of JSX, not a span, something else. So the shared component receives its render logic from the consumer. The consumer is the component at the bottom. The name, really the name of the prop isn't that significant. That's just a convention, I suppose, that has emerged over time. You can call it anything you want to. I mean, I could call the prop here foo, okay? But as long as I'm invoking foo in the middle of the JSX, then really what I'm implementing is this render props pattern. It's kind of general, another kind of use case. So let's supposing I've got this app for displaying blog posts. And within this app, I have two views, amongst others. One view displays the text of a blog post followed by comments that people have left about the blog post. I have another view that displays the text of the blog post followed by, let's say, a series of hyperlinks to related blog posts. So clearly those two views, as I've described them, have a lot in common. So we should be able to share some logic between them somehow. And one way of doing it is by using the render props pattern. Here's how you would implement it if you didn't use render props, and it's really just only an outline now that I'm giving you. So it looks like, so here are my two components that are responsible for rendering the actual pages or views. This looks like the one that's rendering the post followed by the comments. So in its JSX, we don't see this component, but you can imagine what it does, right? It just displays the actual text of the blog post, and then it's followed by a component that displays a list of comments. Might be something like this up here. Here's the component that displays the view consisting of the blog post followed by a list of hyperlinked matching blog posts. And clearly, when you look at these two here, there's a lot in common. I haven't shown you the detail of the hooks and effect code, but my guess is it's going to be actually pretty much identical in both of them. So there's repeating code there, and we don't like that. Okay, it's violating the dry principle. So to refactor these using the render props idea might be something like this. So I've essentially kind of taken the repeating code and I've put it into a new component up here. And the new component, which is going to be the shared one, it's going to be responsible for displaying the text of the blog post. But what it follows the text with depends on the consumer that's actually using the shared component. And here again, we're calling our props.render. And again, I've made the same mistake. I shouldn't have this there, although I did include the props. So I'll just wipe that from your memory. Here's my two consumers, and it's passing in the first one as its render prop. It's passing in a callback function that returns my comment list, and the other one is returning the matching blog post list. Again, there's a lot of detail left out, but hopefully you get the idea. So the render prop is where the consumer supplies to the shared component, it supplies some JSX that it wants the shared component to display for it. Now, these two components might have some logic as well, and that logic is going to be available inside here. it's possible that the render prop function is parameterized. And again, I think that this actually arises in the lab now where I use render props. But the general idea is, here's the consumer. Here's the consumer, and it's passing in its callback function, but it's a parameterized callback. Now, where does this parameter get its actual value from? Well, it's the shared component that actually determines the value for the parameter. We don't need to worry about the specifics of where it gets the parameter value, but it does get it in somewhere in this logic, and it uses that parameter value then when it's actually calling the render prop function. So person.name is computed somewhere up here. That's quite tricky now, the idea that the render prop function is parameterized. But just remember that the parameter value is computed somehow by the shared component. The last pattern, I'm not going to give you a sample implementation of it. It's this higher order component. What you notice about these three patterns is that they kind of achieve the same thing. There are different ways of achieving the same thing, and that is true. There are cases maybe where one is preferable to the other, but in general, they kind of achieve the same thing. In the case of higher order components, it's all about sharing and reusing code as well. What a higher order component is, technically, it's actually a function, despite its name. A higher order component is a function that takes a component as an argument and it returns a component as its return value. And essentially, it enhances the component argument, and how it enhances it can vary. And I'm saying that here, right? Maybe what the higher order component function does is it receives a stateless component and it makes it stateful. Or maybe it passes some extra props into the component that it receives. Or maybe it just enhances the JSX of the component that it receives. And so the component that it returns would have some extra UI. We have actually seen one example of this higher order component idea. The with router method or function that the React Router library provides, it's an example of a higher order component implementation. What the with router function does is it takes your component and it injects some additional props into your component, like the params prop and the history prop and the location prop. Now, okay, we're talking about patterns here, but there is another pattern that I want to look at, which isn't really connected with this whole idea of reusability and separation of concerns. It has a very kind of specific purpose. And really what I'm talking about is something called React context. And the title there, provider pattern, is like all patterns are generic in nature. They're not related to React or web development. That's certainly the case of the provider pattern. So you may be reading about patterns and come across the provider pattern in a completely different language and kind of use case. It does happen to appear in the whole React world as well. But in the React world, when we talk about the provider pattern, what we're really talking about is something called React context. And if you Google React context, you may read lots about it, and they may never mention the provider pattern. The provider pattern just happens to be the foundation on which this React context feature is based on. Now, when do we use the provider pattern, i.e., when do we use React context? And it's quite straightforward, actually. If you've got a number of components in your hierarchy that all want to access some piece of kind of global, what I'm calling global data, then that's an ideal use case for React context. And a particular example of that is maybe your React app retrieves data from a web API, but there are a number of components that actually want to be able to access that web API data. Now, of course, you could pass the data via props to everybody that needs it, but that can result in something called prop drilling. What do I mean by prop drilling? Now, here's a picture I found on the web. I did not draw this picture, so apologies about it, but it does explain this idea of prop drilling. So let's supposing we have a component here at the right top that's stateful, and let's say that component is the one that has the global data, whether it got it from a web API or whatever, we don't care, but it has some global data. And it turns out that this component and this one here needs to know about some parts of that global data. So how does this provide that data to those other components? Well, if we only had props available to us, then what it would mean is this component has to pass props down to this one, to this one, to this one, and eventually get it to this one. And the same over here. But these intermediate components, they don't really use the data at all in this particular use case. So we're passing props through the hierarchy just for the purpose of this component down here at the end and these two down here. And that's an ugly kind of pattern because it means when you look at this component in isolation, you'll see from its specification and in Storybook that it's receiving props, but there's no evidence that it actually uses the props internally at all. And of course it doesn't. All it does is it receives the particular prop and it passes it on to its subordinate. So that's this idea of prop drilling, and it's considered a bad design or an anti-pattern. Now, the way we overcome this is by using React context, because essentially the data that's up here that the other components need is what I'm calling kind of global data. Okay, sorry, now let me just, oh yeah. So how do we fix that prop drilling problem on the previous slide? And there are a couple of parts to it. So, well, sorry, the answer is we implement the provider pattern. And in doing that, we use this idea of React context. So the provider pattern has a number of parts to it. Number one, we have to declare a component which we call the provider. And that's the component that's going to be managing the global data. So maybe it's the one that makes the web API call. Number two, then, that global data in the provider component, it makes its data accessible by other components, which we call consumers. Now, number two there is where this whole idea of contexts come in, but we'll talk about that in a second. And number three, then, we somehow compose the component in number one, the provider, with the components in number two, the consumers. And I'm doing the composition using the container pattern. So that's a very high level kind of explanation as to how we implement this provider pattern. We have one component that is the provider. That's the one that manages the global state. We have other components which are consumers. They're the ones that want to access the global state. And we compose those two together. Now, in the middle of all of this is this thing called a context. And I'm saying it's the glue behind the provider pattern in React. And what is a context? A context provides a way to pass data down through your component hierarchy without actually using props. That's kind of what I want to achieve. I want to make my global data available to lots of components, but I don't want to do it using props because that introduces prop drilling. And what's the second point? Sorry, the provider. Oh yeah, the provider component is the one that actually creates the context, and it makes the context available to the consumers. What the consumers have to do is they have to indicate that they want to access the context, and they do that via another hook that we're going to talk about, which is the use context hook. It's all a bit vague, I know, right now so far. Here's a kind of visualization of it. So the orange box on the left there is my representation of this context. And the orange box is created by the provider. My provider is the one that has the global state. So it creates this orange box and it puts data into it. Turns out that I can actually also put functions into it. So that's one part of the story. And the other part then, and I'm just representing them by arrows, these are my consumers. And they can access that context directly. And they will be able to do that by using a special hook called the use context hook. So that's kind of a visualization of it, but the implementation is quite fragmented now. So let's try and get through it one by one. Here's an outline of a provider component. The things to note are, here's how you actually create a context. And note we're actually creating it outside the component, but that's okay. Here's how you create a context. So it creates my orange box. Notice that I'm actually exporting a reference to the context. Here's the provider component. And it has some use state and use effect logic to grab the global data, let's say, from a web API. So we can visualize what that code might look like. It's ordinary use state, use effect stuff. Now, here's how I kind of link the state data here with the context. This is how I actually do it. It's not straightforward, but so you take the context, because that's what I call the context up here. You take the context and you access a property of it called provider. Just take that as boilerplate for now, I'm afraid. And here's a prop which you have to call value, and you assign the value prop an object of a set of key value pairs. And the key value pairs here will refer to the parts of the context that you want to make available to everybody else. Notice here how I'm using the container, or sorry, I'm using composition, using the container pattern. So I am going to be combining this provider with other components. And those other components will be able to access the particular key value pairs that you're exposing here. And the key value pairs that you are exposing here will be coming from the state that you have declared. And they will also be implicitly stored in the context. So there's a lot going on there now, but let's take that for now. That's my provider. Declare your context, do your normal use state, use effect stuff to access the local data. And then inside here in the value, that's where you specify which parts of the state that you have here, which parts are you making available as context data to the rest of the application. Like behind the scenes, the effect of this here is to essentially put these key value pairs into the context for us. That's my provider. Here's where I'm just doing the composition. And you typically a context component, a context provider, sorry. The component here, context provider, is the one that I defined on the previous slide. Not the context now, it's the actual provider component. I am composing it with whatever consumers I want to have, that I want to have access to the context. Typically, we would put this at the very top component in our hierarchy, and that's where I put it in the Movies app. So I haven't been specific here about what ... is, but it's going to be essentially the rest of the app's component hierarchy, which means that every other component can now potentially have access to the context. And what do I mean by the context? I mean whatever key value pairs you've put in here. Here's the consumer, and the things to note here are the consumer has to import the use context hook, and it also has to import the context declaration itself. This here now, and I'm sorry now for jumping around, this here is a reference to this. So my consumer, so it uses the hook, it specifies the particular context that it's interested in, and there may be more than one. The use context hook returns a reference to the values object that the provider initialized. This here is going to be a reference to this object here. Hence, the consumer now has access to particular global data that has been put into the context by the provider. Now, I'll be honest, it is quite ugly, the implementation, but once you've seen one implementation of the context provider, they all follow the exact same structure. Declare a context, declare your provider component, hook up the provider component with the context, which is what we're doing here. Do your composition, which we're doing here. And then in the consumers, use the use context hook and access the particular values that you're interested, that particular component is interested in. Maybe I'll come back to, sorry, how are we in time? Yeah, the only reason I'm including this slide here is just for completeness sake. Like, there are some cases when it's not a good idea to use the provider pattern. If the prop drilling is only for going from one level down, where a component passes props down to just one child, then you shouldn't use context for that kind of scenario. Prop drilling is actually faster than using a context. I wouldn't worry much about this explanation here, actually. I'm just going to skip over it because I realize the implementation or the explanation here, is quite difficult to follow. I do use it in part 4 of the Movies app, and so you'll have an actual, something tangible to work off of from there.